Hello, so we're just going to quickly review impulse, which is the last thing linked to momentum. So we know that by definition, the impulse of an object is its change in momentum. Okay, now we can refer to that as delta P, where that just means change in and this means momentum. Okay, now we know that momentum, come on screen, just focus for me. Momentum is mass times velocity. Okay, so this is going to be equal to mv after minus mv before. Okay, so this is momentum of an object after a collision or an explosion, and this is momentum before. Okay, so when a force is applied to an object, it changes its momentum. Okay, and so this is after, this is before, this is the change in. Now I can actually express this as mv minus mu. Okay, where v is final velocity and u is initial velocity. And I can go one step further and I can pop v minus u into brackets, and then you can multiply it and see it's the same. Okay, so this is the impulse, the change in momentum of an object. Okay, considering it has a constant mass, you can find its change in velocity, and the product of that is the change in momentum of an object. Its unit is still going to be the same as the unit of momentum. It's still going to be in kilogram meters per second, because it's still a mass multiplied by a velocity value. But what you might have seen in your textbook that you might be a little bit confused by is why we can also say that impulse is equal to force multiplied by time, and that's what we need to have a little look at. Now to do this, you need to remember Newton's second law, so F equals ma, force is mass times acceleration. And you also need to remember the equation for acceleration. So acceleration is change in velocity over time. So that's v take u over t. Okay, the rate of change of velocity. Now what I'm going to do is I'm going to take this expression for acceleration and put it in here, so that I can say F equals m multiplied by v take u over t. Okay, and then I'm finally going to multiply both sides by t. Okay, so I get ft, so I'm multiplying this by t, is equal to m v take u over t times t. Okay, and hopefully you can see that these two t's cancel, and I'm left with this expression. And so what I've done is I've proved that change in momentum, which is impulse, is also equal to the product of force and time. So if an object has a force exerted on it for a time t, the product of force and time is the change in momentum. Okay, now it could be in a question that they give you the force value, the time, the mass and the initial velocity, and they then ask you what the final velocity of the object is. Okay, so they might say you have an object with a mass 2 kilograms, for example. Okay, and initially it's travelling to the right at 10 meters per second. But now suddenly a force is exerted on it to the right of 2 newtons acting for 5 seconds. Okay, so it might then say, what is the final velocity of the object? And we can do that because we now have everything that we need. Okay, so we can say that Ft equals mv minus mu. And now I know that I've got 2 times 5 must be equal to mv minus mu. So So I've got 10 equals 2 times 10 minus 2 times v minus 2 times 10. Let me move this down so you can see this a little bit. Okay, so I've got force times time, 10. The mass is 2 kilograms. The final velocity is unknown, that's what we're trying to work out. And we have the mass and the initial velocity here. Okay, so I've got 10 equals 2v minus 20. And what I do is I then add 20 to both sides so that I'm left with just an expression for v. So I get 30 equals 2v. And so v is equal to 30 over 2 is 15 meters per second. Okay? And so I know that if I exert a force of 2 newtons for 5 seconds, I can work out the final velocity. Okay? Now, the other instance, though, is where the force is not in the direction of the initial velocity and it's acting against it. And quite